Hello students, again welcome. Today we are in module 3rd and we are to start from inverse function. Till now in module 2, say this. If this is a mapping, this is called many one function. Many one into function. Many one, and because one element left here, it is called into function. If we are mapping this, this is called many one onto function. Many one onto. Next, suppose this is the mapping from A to B. This is called one into function. One into function. And if mapping is this, this is called one onto function. And when one function is one onto both, one means every element has distinct answer. Onto, every element of codomain has the image. Every element of image of at least one element of it. When function is one onto both, then inverse, this is called inverse, exists. If this is function, this is called inverse. So again, suppose there are three numbers in a domain, three numbers in codomain. They are the images, it is the image, and it is the function f. So F1 answer is B, F2 answer is A, F3 answer is C, and because it is 1 and 1 and onto both, therefore inverse exists. What is inverse? Inverse is a function from B to B. If function from A to B, inverse from B to A. And what is inverse? Inverse of B. Inverse of B, answer is 1. Inverse of A, answer is 2. Inverse of C, answer is 3. F is 1 onto function from A to B. Inverse is function from B to A. Those which are images, it is called domain. It is called codomain. Now codomain becomes domain and domain becomes codomain. Inverse is the function from B to A. If F is function from A to B, inverse is from B to A. But first condition, function should be 1 and onto both. Let us take one example. If question is, if f is the function from R to R, if f is the function from R to R, such that, and question is, check whether f is invertible, and if possible, find f inverse. Check whether f is invertible, means you have to check whether f is 1 onto both, then you have to find inverse. This is inverse, not minus 1. So when we have to check invertible, we have to check f is 1 1 or not, f is onto or not. If both, then invertible. And for 1 1, let x1 x2 belongs to R such that fx1 equal to fx2. Similarly, 2x1 plus 3 equal to 2x2 plus 3. And next line, x1 equal to x2. Therefore, f is 1 1. For onto, let y belongs to R such that y is equal to fx. Y is equal to 2x plus 3. From this, find the value of x. X is y minus 3 by 2. Whether this value belongs to R? Yes, this belongs to R. Therefore, f is onto. Now, when f is 1 1 onto both, therefore, inverse exists. If f is from R to R, inverse is also from R to R, but inverse from this R to this R. Inverse exists. And now question is, find out inverse. Now, how we can find inverse? To find inverse, see first line. Let y belongs to R. There exists x belongs to R such that y is equal to fx. See first line. Now what is this first line? This first line is proof of onto. Let y belongs to R. There exists x belongs to R. For every y, we have proved that x belongs to R. For y belongs to R, there exists x belongs to R such that y equal to fx. You have to write the first line this, second line this, which you have proved in onto, and then start this. Y equal to fx. Next line y equal to 2x plus 3. Next line x is equal to y minus 3 by 2. Next it is card inverse. This is card inverse. In the end you can write f inverse x is equal to x minus 3. Second, in this question, suppose in this question, same question, fx is 2x plus 3. Fx is 2x plus 3. Suppose here is one number 1 in domain. This is also f is from R to 1. If one number is here, its image is, when we put 1 here, answer is 5. When we put 2 here, answer is 7. When we put 3, answer is 9. This is f. Now I need inverse. See this inverse? Inverse of 5. Inverse of 5 should be 1. Put 5 here. This is inverse. Put 5 here. 5 minus 3 by 2. It is equal to 1. Inverse of 7 should be 2. Put 7 here. 7 minus 3 by 2. It is equal to. Inverse of 9. When I put 9 here, 9 minus 3 by 2. It is equal to 3. If I put 5 here, I should get 1 answer. If I put 7 here, I should get 2 answers. If I put 9, we get this answer. If f is function from 1 to 5, inverse 5 to 1. So inverse start from codomain to this domain. So you are to write down for inverse, y belongs to R, first line, x belongs to this R, such that y equal to fx. Proceed like this, and this x, this is called inverse. If some student says, sir, why you have put x here? See, x is always in domain, y is always in range. For x we get y, if this is the function. From x we reach y. What is inverse? Inverse start from here. From codomain to this domain. So y for this f, y means range. For this f is domain of f inverse. This y is range for this f, and this y is domain for inverse. So this y which is range for f, it is now domain, and domain we say x, so that's why this y is now x. This x and this x, they are not same. This x means 1, 2, 3. This x means 5, 7, 9. F inverse operate on 5, 7, 9. Here we get this answer. And this x means domain 1, 2, 3. We get this answer. Firstly, we have to check whether it is invertible or not. Means 1, 1 on 2. And then we have to find inverse. If 1, 1 on 2 out of these two, any one condition does not hold, inverse does not exist. See one example more. Suppose f is a function from 1 to 3 to ABC, and it is given f1 answer is A, f2 answer is B, f3 answer is C. And question is, show that f inverse is F. It means 2 times I have to take inverse. It is given, this I have to do. Now firstly what I will do, because f is function from 1 to 3 to ABC such that f1 is A, f2 is B, f3 is C, it is given, therefore f is 1, 1. What is 1, 1? Every number has distinct answer. And also, codomain is equal to range. Codomain, range. Therefore, f is on 2. And when f is 1, 1 on to both, therefore, inverse exists. And inverse start from ABC. ABC 2, 1, 2, 3. Now what is inverse? Such that inverse here, inverse of A. Inverse of A is 1, inverse of B is 2, inverse of C is 3. Because this f is 1, 1 also, on 2 also, therefore inverse exists. Inverse of A is 1, inverse of B is 2, inverse of C is 3. Now see here. Here f inverse is also 1, because every number has distinct answer. And also codomain is equal to range here. See, codomain, range. And therefore f inverse exists. Its inverse also exists, such that f inverse, it is from 1, 2, 3 to ABC. F is from 1, 2, 3 to ABC. Inverse is from ABC to 1, 2, 3. And its inverse from 1 to 3 to ABC. Such that now see, inverse, its inverse of 1 is A, inverse of 2 is B, f inverse of 3 is C. So its inverse, f inverse of 1 is A, f inverse of 2 is B, 3 is C. Now this and this they are same. F is from 1, 2, 3 to ABC. F inverse 1, 2, 3 to ABC. F1 answer A, 2 answer B, 3 answer C. Inverse 1 answer A, 2 answer B. And therefore you have to write down inverse. When function is 1, 1 onto both, then inverse exists. Inverse start from codomain to domain. Now it is domain. It is codomain. When it is 1 1 on 2, its inverse exists. And its inverse from 1 to 3, ABC. And when these all value and these all value they are same, therefore inverse is equal to f. So inverse exists when function is 1 1 on 2 both. Same. Next example. Let f is a function. Check invertibility and find inverse. When question is check invertibility, it means you have to check 1 1 on 2 and then question is find out inverse. So again, for 1 1, let x1 x2 belongs to R plus such that fx1 equal to fx2. Next line, okay, function is fx equal to x square plus 4. This function. So fx1 equal to fx2 means x1 square plus 4 equal to x2 square plus 4. Next line, x1 square is equal to x2 square. Next line, x1 equal to plus minus x2. But because x1, x2 both belongs to R plus, therefore there is only one possibility and therefore f is 1. Onto. For onto, let y belongs to such that next line y is equal to, from this you have to find the value of x. So next line x square is equal to, x is equal to, see, y is from 4 to infinity. All the numbers from 4 to infinity. If I put 4, I'll get 0. If I put 5, I'll get root 1. 6, positive. All the values, not negative, positive. X equal to this under root y minus 4. This value belongs to R plus. Therefore, f is on 2. 1 1, start from here, reach x1 to x2. On 2, start from this, prove that x belongs to this. Therefore, f is 1 1 on 2 both, and therefore f inverse exists. Now, to find f inverse, yes, first line, let y belongs to, first line. Second line, there exists x belongs to such that this you have written, but you have proved in onto. For y, x belongs to this. Y equal to fx. Now proceed like this. Next line, y equal to, same, x square equal to, x equal to, and x equal to this value. Because negative does not exist, x equal to this is called. In the end, you can write f inverse x equal to start from y equal to fx, put the value of fx, find the value of x, and this x is inverse y. Again see, this is x, this is y. F operate on x, we get y. F operate on x, we get y. And F inverse operate on y, we get x. F inverse y, we get x. X is F inverse y. X is F inverse y. So this is F inverse y, this is F inverse x. Firstly, you have to prove 1, 1. Then you have to prove onto. If 1, 1, onto both exist, then inverse, then this. So again, next question. Question is, f is a function from -1 to 1 to r such that fx equal to, show that f is 1, 1, and also find inverse of f from -1 to 1 to range r. See this question. F is a function from -1 to 1 r. This is given to you. Show that 1, 1. Find out inverse. In the question, it was not written that you have to check onto or not onto. Why it is so? Firstly, we start 1, 1. So for 1, 1, yes, let x1, x2 belongs to such that next time x1 upon x2 upon, start from fx1 equal to fx2. This is fx1, this is fx2. Next step, cross multiply. So I'll get x1, x2, 2x1, x1, x2, 2x2. It will cancel. Next line is, therefore f is 1, 1. You have to take x1, x2 from -1 to 1 such that fx1 equal to fx2. This is fx1, this is fx2. Cross multiply and reach here 1, 1. Now after this, he has not written about onto, because when we start this function for onto, it is not onto. Why? See, if I start this question, not this, for onto, let y belongs to such that y equal to this. You have to find the value of x. When we cross multiply, we get yx plus 2y equal to x. Because we need x, all the terms which contain x, they should be transferred. Take x common, anyhow find the value of x. All the terms which contain x, they should be transferred to one side. Take x common, find the value of x. And now see whether this value belongs to this. No. Why? Because y belongs to r. And when y belongs to r, it means y is positive also, negative also. So y may be 1. And when y is 1, it will not exist. Something by 0. So this function is not onto. Now what written in the question? Show it is 1, 1. Find inverse of this. Now what is the change here? See. He has not asked about this, but what he has done, instead of this codomain, he has written this. Now it is codomain. So here codomain is range. It is given in the question, range. Codomain is range. Therefore, f is onto. It is onto, not this. It is onto. And therefore, inverse exists. Its inverse does not exist. But instead of this, if I add on this, it means codomain and range both are same, and therefore it is onto, and now inverse exists. And now to find inverse. First step, let y belongs to, because it is onto, it is given it is onto, y belongs to range of f, there exists x belongs to -1 to 1 such that y equal to fx. Next line, y equal to cross multiply all the terms which contain x, they should be transferred. Take x common, find the value of x, and this x is called inverse. And you can write this also. And next line, inverse x is this function is 1 1 but not onto. That's why instead of this codomain he has written this range. So codomain changes to range, and when codomain range they are same, it is onto. So no need to prove onto. Now we have to find inverse, and when we have to find inverse, because it is onto, for every y there is x, because it is onto, such that y equal to fx, write the value of x, find the x, and this x is called inverse y. Take minus common, minus cancel, and f inverse y, we can write f inverse x, this is f inverse x. When function is 1 1, when function is onto, then inverse, and then start the steps and find the inverse. See this? Let us do one question more. Question is, f is the function from r plus to minus 5 infinity such that fx equal to 9x square plus 6x minus 5. Now show f is invertible and find f inverse. See this question. F is function from r plus to this minus 5 to infinity. It is open here, close bracket, minus 5 is here. Fx equal to 9x square plus 6x minus 5, and f is, show that f is invertible and find out inverse. Means we have to prove it is 1 1, it is onto, and then find out this. So let us firstly start 1 1. So starting, let x1, x2 such that fx1 equal to fx2. Write down fx1, 9x1 square plus 6x1 minus 5 equal to 9x2 square plus 6x2 minus 5. This 5 cancel. All the term transfer. So 9x1 square minus 9x2 square plus 6x1 minus 6x2 equal to 0. From this you can take 9 common, 6 common. From these two you can take 3 times x1 minus x2 common. Because it has factor x minus 1, x1 minus x2, x1 plus x2, take x1 minus x2 common. So remaining 3 times plus 2. Next line, 3x1 minus x2, it is 3x1 plus 3x2 plus 2. These two multiplication equal to 0. So next line, therefore either x1 minus x2 equal to 0 or 9x1, 9x2 or 3x1 plus 3x2 plus 2 equals 0. This is not possible. Why? Because x1, x2 both are positive number. Both are positive number. And when it is positive, this total answer can't be equal to 0. And therefore there is only one possibility, and therefore f is 1. It is quadrication. Start x1, x2 belongs to R plus such that fx1 equal to fx2. This is fx1, this is fx2. Square combine with square, singleton combine with singleton. Take common, either this equal to 0 or this equal to 0. This is not possible, only one possibility, and therefore 1. Let us start on 2. For on 2, let y belongs to such that y equal to fx. So therefore y is equal to 9x cube plus 6x minus 5. All the term transferred. 9x square plus 6x minus 5 minus y equal to 0. It is quadrication. So we can find x equal. What is a here? 9. What is b here? 6. What is c here? How you can find x equal to minus b plus minus under root d by 2a. So x is equal to minus b plus minus under root. What is d? B square minus 4a c divided by 2a twice a. From this you are to take 36 common. So x is equal to minus 6 plus minus, take 36 common, means we get 6 here, and here 1 minus 5 minus y divided by 18. 6 cancel. So x is equal to minus 1 plus minus under root 6 plus y divided by 3. So there are two answers. X equal to minus 1 plus under root 6 plus y by 3. And second, x equal to minus 1 minus. This value not belongs to R plus, because both are negative, not belongs to R plus. Now check this. Y from minus 5 to infinity. So put any number from minus 5 to infinity. If I take minus 5 here, think y equal to minus 5. Minus 5 plus 6. So 1 root is 1. 1 minus 1, 0. X equal to 0 belongs to this. Because R plus means 0 to infinity. What is the meaning of R plus? 0 to infinity. Again see, we are to put number from minus 5 to infinity. Any number from minus 5 to infinity. Because it is close bracket, so first number is minus 5. When I put minus 5 here, plus 6 here, it is 1. 1 root is 1. It is 1. It is 1. It is minus 1. And 1 minus 1 0, and 0 belongs to this. When I put any value belongs to, x belongs to R plus. This value belongs to R plus, and therefore f is 1, 2. Now it is 1 1 also, 1 2 also, therefore inverse exists. And to find inverse, you are to write an onto in short way. Means let y belongs to first line. There exists x belongs to R plus such that y is equal to and write in the same way. In the end you will get x is equal to this minus 1 plus under root 6 plus y by 3, and this x is called inverse. Inverse of y is, and therefore inverse of x is. This is inverse. Firstly, prove 1 1, then prove onto. When 1 1 onto both, then inverse exists. And when we are to find inverse, write just as you have written in onto. First line y belongs to, second line x belongs to, such that y equal to fx. Proceed in the same way, and this value of x, this is our inverse y, and instead of y you can write x. This is also correct, this is also correct. So till now we have studied 1 1, onto, bijective, surjective, injective, and inverse. Now in function chapter, one part left, that is composite function. This is last part of function chapter, composite function. This I will discuss in next module. Okay, this from my side.